remember, pendulum is one kind of periodic motion, and we are going to describe the parts that form a pendulum. First, we have the pivot, which is the part where it hangs from. Another element is the mass, which is what is hanging on the pendulum, the weight. And we also have the arm length, which is the object that is the distance between the pivot and the mass. These are the three elements that form a pendulum, and they are very important for this topic. Now, pendulums have been used for a long time. Actually, we don't even know when pendulums were started to be used by people. The first accounts we have is some findings from a cave in Africa, but we still aren't sure of when they started using it. Later on, there have been found traces of semiscopes. These are used to detect earthquakes, and they were used as early as 132 AD. Next, in the 16th century, Galileo Galilei was observing chandeliers swaying with the wind, and he discovered that they had a periodic motion. He said that they move at a constant rate. In that time, they didn't have really exact clocks, so what did he do to know that they were swaying at a constant rate? He used his pulse to measure the rate of the movement. And after he discovered that, he started designing a pendulum clock. He was the first one to design a pendulum clock, but it was very early on and he didn't get to complete it. It was until 1656 that the first actual pendulum clock was completed, and it was by Christian Huygens. He used Galileo's design as a base, and he made some improvements, and he made someone build the first pendulum clock. And since then there have been some changes, and we have discovered new things. After Newton discovered the movement laws, we discovered that inertia is part of what happens. We discovered that gravity is part of the forces that act on the pendulum that makes it move, etc. Until we have the model that we have today. Now, what makes a pendulum move? The movement, as we were saying yesterday, is the result of two forces: the force of gravity and the resistance force of the arm. It has a tension. If we try to pull it back down, we will feel the tension. That is the arm's tension, and it is pulling up, and also gravity is pulling down. That's what keeps it in its place. But since gravity is always the same in everywhere on the earth, we are going to take it in as a constant. So the only factor that really affects is the arm length. And since we discovered that, scientists have come up with a formula to calculate the period of a pendulum. The period of a pendulum, remember, is the amount of time it takes to complete one cycle. Okay? The time it takes from the resting position to go back, forth, and return to the resting position. We can calculate the period of any pendulum if we use this formula. Period is represented with a uppercase T, remember, because it's time we are measuring. And the formula says that the period equals 2 times pi multiplied by the square root of the arm length divided by gravity. Okay, so the T represents period, pi, we all know it. The L is the arm length, and G is gravity. Now, in your presentation, you have an example problem, and we are going to solve it using this formula. The problem says, what is the period in seconds of a pendulum that has an arm length of 0.2485 thousandths meters long? And for what purpose would such a pendulum be useful? Okay, what data do we have? They are asking us for the period. We know that gravity equals 9.8 meters per square second. We know that 2 times pi, if pi is 3.14, 2 times pi is 6.28. It has no units. And the arm length they are giving us is 0.2485 meters. We substitute all the data into the formula, and we have that the period equals 6.28 multiplied by the square root of 0.2485 meters divided by 9.81 meters per square second. And we have that the period equals approximately 1 second. So, if our pendulum takes 1 second per cycle, what use could we give to that pendulum? It could be used for a clock. That's it for today. I hope this class was clear enough. And if you have any questions, don't forget to log in for the Facebook Live Q&A. Bye-bye.